Hello everyone, this is Shuo, the master student from KAIST UVR lab. Here, I'd like to present my research topic, which is evaluation of sharing hand gesture and 3D virtual model in the mixed reality remote collaboration system. Okay, let's start with the research goals. There are two research goals in this study. The first one is to evaluate the performance of single gesture, single virtual model, and the combination of these two. In this study, I'll just focus on the expert no-wins collaboration relationship, and all of these three visual cues will be tested in terms of completion time, accuracy, usability, feeling of cooperation, and the mental effort. There are some previous related work indicated that visual cues will have different effect on different size target objects. So in the experiment, I'll prepare the target objects in big or small size. After conducting the experiment, I hope the result can be used to promote the design suggestions on annotations within the AR and VR remote collaboration system. In this system, the local users who are no-wins will use the AR HMD, and the remote users who are the expert will use the VR HMD. The results of this study will be measured in both quantitative and qualitative way. Before the experiment, we need to understand some basic information of the participants, such as how familiar they are with the AR devices, VR devices, or remote collaboration system, so that the participants will be asked to fill out the demographic questionnaire. As the verbal communication is a very important part during the collaboration process. So the words used by the users will be recorded and classified into types of phrases. Also, I will collect the participants' preference to let them rank all trails in order of specific aspects. To avoid any missing of the result, I will have an interview with every participant and let them comment on the feelings or the suggestions on tested visual cues. I also collect qualitative data during the experiment period. The completion time and accuracy can be got from the screen recording. Every participant have to fill out a system usability scale questionnaire, which can reflect the usability of each visual cue. Social presence and spatial presence can be digitalized by the relative presence questionnaire. And with the help of NASA task load index questionnaire, it's easy and accurate to measure the user's task load. Since March to June, I will determine the detailed variables of selected visual cues according to the previous related work, and then I will conduct the experiment, starting with the building of experiment system. I hope I can collect and analyze valuable data to generate the convincing results. Maybe because it's a new trend, there is not so much research discussing about regarding virtual model as an annotation in the remote collaboration system. Here, I'd like to explain why I regard the gesture and virtual model as my research object. The reason one is the updates on the system. In the previous related research, researchers usually include the traditional desktop or tablet in their remote collaboration system. However, with the development of devices and tracking technologies, remote collaboration system turns into consisting of AR and VR devices. Um, that means it has more potential to be embedded with 3D interactions. To be more specific, it refers to more nature interaction with gesture and virtual model in terms of annotation. Reason 2 comes from the disadvantages of cursor pointer and pen-based drawing tool. These two can be regarded both as the alternatives of gesture. For cursor pointers, it lost the function of indicating the direction and angle of insertion and orientation, which is regarded as a crucial part of collaboration tasks. And some research even indicated that the pointer only brings little benefits over a video-only camera. Sketches, which is discussed the most, also has its own drawbacks. When moving the camera, the alignment of drawing to the screen can break. That means it takes more time on redrawing for the users. And when working with the 3D workspace, sketches show the limitations, especially with the complex parts. And as it needs to switch interaction from live video to still image well. Sketches usually bring more task load, and the participants who are in the expert role reported that they felt more time pressure than usual on checking what is going on with the task process. On the basis of the results coming from related studies, I made my own hypotheses. I think combination of 3D hand gesture and virtual model shortens the task completion time and at the same time improves the accuracy. A combination of 3D hand gesture and virtual model makes better usability. More annotations make users have higher feelings of cooperation, and more annotations lead to more mental effort. Here, I primarily designed the experiment task, which is a diverse dimensional task. Participants need to place and assemble the objects in different size on a 2D surface or in a scene with multiple surfaces of different height. And Lego will be used as the experiment materials. Here are 3 reasons why I choose Lego. First, it can be regarded as a presentation of remote guidance on physical objects because it has components that can be found in a range of real-world physical tasks, such as assemble, disassemble, select, and rotate. And it's easy to digitalize the performance and calculate the accuracy with its precise orientation. And I believe everyone must have played with toy assembly toy during his or her childhood, so there is no learning cost It means it's easy for the participants to finish the task. I briefly designed the remote collaboration system for this study. So the local users who are in the worker role will wear Air HMD to see the annotations from experts, and the remote users who are in the role of expert will use the Microsoft Kinect to capture the gesture, and where HMD will show them the real-time manipulation feedback from workers. And in this system, I think we need to have a 3D virtual space reconstruction, so the depth cameras are necessary. Okay, the benefits. I hope at the end of this study, I can conclude the more suitable and intuitive annotation method for AR/VR remote collaboration system. And this new annotation can make up the disadvantage of traditional cursor pointer and sketches. And I hope I can provide users a new choice to accomplish the collaboration task. Here is my schedule of the study. So I plan to review the related work and refine the research issue during the January and February, which I almost done. So since next month, which is March, I'll start with designing the experiment system and then build the collaboration system, recruit the participant, conduct the experiment, and analyze data. Um, I think if everything goes well, since the middle of May, I'll collate all research results. Because this study is also my dissertation, and now I'm preparing for the graduation. So I hope everything goes well. Okay, this is the end of my presentation. Thank you for your listening, and hope everyone have a nice day. Bye bye.